All right, so you found the quick review to lesson 2.1, relations and functions. And so, hey, just trying to, in a couple minutes, and of course this is Algebra 2, so it's a little bit longer, give you the main concepts. All right, don't forget the aspect of x-intercepts and y-intercepts. We can also call an x-intercept 0. So this function has an x-intercept or a 0 there, right? It would be the x-coordinate when the y-coordinate is 0. It has one there, and it has one there. Now some of them are hard to read because they're not right on the line, such is the case with some x-intercepts. Remember, the y-intercept is the y-coordinate when the function crosses the y-axis. In that case, the x will always be 0. And we talked about mathematically how to find them. Right? Here we can find them visually to find them mathematically. How do you find an x-intercept? Put in 0 for y, solve for x. How do you find a y-intercept? Put in 0 for x, solve for y. All right. The other thing we talked about, functions and relations. Do you remember the test for a function? It's called the vertical line test. If no matter what line you choose, it only hits one point of the function. Or we could say it this way, if there exists a line, a vertical line, that hits 2 points, then it is not a function. This is a function. Okay, no matter what vertical line you choose, it only hits in 1 point, therefore it's a function. Now you can see this one, it's a little bit different. This one is definitely not a function. All right, because, all right, I can find a vertical line. Oh, that was cool. I can find a vertical line that intersects the function in more than 1 point, and you can see hitting in those two. All right, so on this one, again, clearly there's the 0 or the x-intercept. So that one looks like clearly 4x value of 4, y of 0. And here is the y-intercept and a y value of 4, x value of 0. Cool. Another thing we can talk about with functions is the domain and the range. All right, the domain are all the possible x values where the function is located. Now, this function goes forever to the left. Therefore, negative infinity is all part of the domain. But the function does not go past 5. So it would be parentheses, negative infinity, 5, bracket, because it does look like it hits the 5. So the domain is any values of negative infinity to 5, but you don't find the function past 5 horizontally. What about the domain? That's the up, down. Well, what's the lowest value? Well, you got a negative 3, but the negative 3 is not included. And again, this thing goes forever up, so to infinity. So so anything bigger than negative 3 to infinity. You could have also said it this way, y is greater than negative 3. Okay? We could have also said the domain as x is less than or equal to 5. Two different ways of saying the exact same thing. All right, what else do we do with lesson 1? And that was graphing. And so we're going to graph. All right, don't let this throw you off. Here's the function. Here's what we're graphing. And this tells us only with values of negative 4. So it's got to be just bigger than negative 4 and all the way up to 1. Okay, because I know this is linear, and we'll work on that, on how you can know that as well. I'm going to do an XY chart, and I'm going to use this value, negative 4, for my x. So I'm putting that in right here. 2 times negative 4 is a negative 8. Negative 8 plus 4 is a negative 4. So when the x is negative 4, the y is negative 4. Now I know that my function can't be this value, so I'm going to put a circle around it. Negative 4, negative 4. And I know that because of the less than symbol. But it's every point just after that. And then I'm just going to do the last point. I'm going to do 1. 2 times 1 is 2. 2 and 4 is 6. And I know I have the point of 1, 6. But that's where it stops. So I put a dot there, and I'm just going to draw the line between them. Okay, and I've just drawn that function. I was restricted to only these domain values, just bigger than negative 4, all the way up to and including 1. And so we graph the function. All right, that's the idea.